Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Everbridge. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead, but first, I have just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude the webinar today. If you have any questions for Tom, we want you to go ahead and send those into the Q&A tab on the right side of your screen. And for any other comments or anything to further our conversation, we want you to direct those comments to the chat tab. We also have today's slideshow available for download in the Handouts tab. So if you want to download that so you can follow along at your own pace, you are free to do so. And finally, at the conclusion of our webinar, we will have a drawing for 4 $25 Amazon gift cards, so stick around. So our topic today is managing response in the evolving cyber threat landscape, and I'm joined by Tom Weatherford, Strategic Solutions Architect at xMatters, an Everbridge company. Tom, thank you so much for being here with me today. I'm going to go ahead and turn the floor over to you.
Hello, everyone. It's a privilege to be here today. I get opinionated and I like to share some ideas to help people think and make sure that we incorporate all that we need to in planning to run a great business. And on the agenda today, we're going to kind of build a common foundation to make sure we understand some of the basics from where I'm coming. And then we're going to start talking about operational resilience, that a lot of people are buying some really excellent monitoring tools and their capabilities, and they're kind of leaving it there thinking the monitoring tool takes care of a lot. And we'll kind of get in that, no, monitoring is just the beginning. You have to be able to do something with it where it goes through there. And in order to do that, we're going to evaluate whether the team is fully organized and ready for a major cyber event, such as something, a ransomware attack that takes off half of your machines in a server, something major. Do you have the infrastructure and the planning and know enough about your people and environment to take care of that? And then this idea of cyber threat containment. What are you going to do if something expected happens? And that would be the best scenario. Worst case, and what it typically is you get a new threat that hasn't been identified before, and you need to be able to contain it and respond to it. And we'll talk about some tips on kind of how to get through that. And finally, I'm this proponent of automation, that I like systems and computers to do as much for me as possible. And I really like that for my engineering team, and especially my experts that are responsible for making sure that things run. We actually want to give them the time to use their expertise. I don't want them mucking through websites and systems and cutting and pasting data and opening tickets when they don't need to. So, kind of that idea where we're heading today, the thought process from which we're doing it, and if you have any questions along the way here, put those in the question and answer tab off to the side, and we will work on getting those into the system. And we're going to start off by establishing this common concept of where we are in the system. And IT organizations, cyber threat environment, the security shop, developers, IT, we've got issues out there. And the industry is problems. They're trying to get through this, and you've got managers trying to tell you to do it quickly. And this idea that you could actually have a team spending up to 72% of their time fixing issues is a major waste, that we want to try and prevent that as much as possible. Even taking 10-15% off of that by having good processes in place and good forethought would actually allow us to get through this and make a sizable improvement for the organization. And kind of that thing I'm going to harp on without this is my last topic down there, that siloed teams and data. We tend to have developers, IT operators, network operations center, security operations center, a security shop. We have testers, and we all kind of do our thing. We convince managers, yeah, we meet once a week in the conference room. Sure, we're working together, but we really don't. And in order to handle and respond to a cyber threat, I need to know my peers on those other teams. And we need to be able to work together. And we need to work at breaking down those silos and start that communication. And that starts with your managers and directors, that they themselves tend to encourage this behavior, and they need to change their habits so that you view the organization as a team working together as we go through this. And those managers and directors today, we've seen the stats out there that about $2 trillion is going to be spent to move more into the digital world, to automate things, to get us up in the cloud as appropriate, to actually make sure that we can get code out the door faster. Keep that resilient system that the customer likes, that operates out there and is available for them when they need it, is important. And we want to make sure we do that without causing more issues. The reality is, as you move faster, I tend to have more issues initially. I need to learn from that and fix my processes to reduce them. And with that, I want to kind of look at this value chain concept, how we move things through the system. We typically see this type of an environment out there. People kind of look at it like this, and this becomes one of the exceptions, that we're kind of comfortable in our silos and working through this. And I am not a proponent of this slide. And the fact that, the cyber threat should be able to be identified anywhere, not just at the security point. So we want to change the way we're thinking about this. The security experts on the security team need to be involved the whole way through the system. We actually want to move that so that security starts with development. When I'm actually writing an epic and putting it into my backlog, the security person is involved reading it. Does this impact security, the stability of the system? Is it a known NIST vulnerability? Are we going to scan it? Is the system designed to be secure? Is the system designed to make sure that threats can't get in the door? We need to consider that starting in the very beginning. Security should be designed into the system as we go through there, and that's how we prevent the cyber threats. We also want to move this monitoring and building of the system instead of just at an end, at a step. This is continuous. The concept of infrastructure as code, it's debatable. That's a different topic. I'm a proponent of it, but it needs to include dev, ops, and security. Having somebody come in like Cody as our miracle worker and actually fix a production system because he spent 4 minutes on the keyboard changing some things and the developer has no clue what he changed does not help the organization and doesn't help my customers. So we want to capture that. We want to control that information as we go through the system. And one of the other things that's occurring more and more is that system monitoring is not just for production. We definitely want to start with our major testing systems and even some of our major development systems. Let your monitoring tools see what they find. I want to find those exceptions as early as possible in this environment. If my monitoring tool can be configured against a test environment for development and it can identify a problem and we fix that early, that's to everyone's advantage. And that kind of value chain that I kind of see as we walk through, I see it a bit differently. We have a development, we deploy, operate. I think just about everybody will consider that. And, you kind of see where we're going. But this last one is something that's overlooked. Part of that whole cyber threat environment. The system also needs to be designed for recovery. In the event that a ransomware attack occurs, our components isolated. Is the database isolated well enough that the database isn't locked up? So all I need to redo is, rebuild the web environment, and I can do that. So we plan for that overall, and again, that recovery of the system, also planning to automate it, bringing those automation tools, pipeline builders, playbooks, letting your existing excellent tools talk to each other, help each other in that total environment. We want to make sure that's enabled from the beginning. And we now kind of get into the topics of the day, now that we have this concept of where we're headed. This idea that a resilient system being something the customer can count on, that you are providing them anytime they want to use it. They really like that. One of the biggest annoyances that Gartner, Forrester, and all the research shows is that when customers come in and the system is not available, it doesn't need to happen very often, and they will abandon you forever. They will move to something else. And today we're doing that by incorporating system monitoring. And we have some really excellent tools that help with that, report with that, and they tell you something's down, the system's getting slow, we're finding memory higher than normal, so we can get in prior to the system actually going down and hopefully mitigate that. But we can do more. And kind of looking at how we work that environment and go through that overall piece, we've got this collection of those tools that generate signals and notify people. They can even kick off some automation routines from what they found based on what you've planned to actually start restoring this while you're waiting for an engineer to get involved. And we also want them to go off and create that ticket so that I follow my corporate standards. If it is a major security incident, yes, I need to follow the corporate standard there for the major incident program that's there, as opposed to a minor defect in the system or piece of code. And I'm going to do that by calling the right person on call to help me start pulling all of this together. So that responder identified usually somewhere inside the IT organization to start looking at what's gone on. The human's going to start pulling these pieces together. I see I've got this error. Yes, there's a ticket open now with some stuff going against it. And I'm going to start looking at my other systems out there. What happened last night? I walked in this morning, the system's offline. Oh, we deployed a new build last night. There was a patch as scheduled. I see that it had a couple known defects against it, and looking around, this application's had similar issues before. The responder might say, oh, I'm just going to rerun the deployment because restarting the server even versus the whole deployment could be a potential fix. But that person is now looking between systems, spending an awful lot of time that they need to become the resource that's going to fix this. And I am a proponent of the idea that there's a much better way of doing this. A lot of this information with planning can be done with systems talking to each other. And as your response grows and you realize this is more critical, at some point, I'm going to ask for help. I'm going to ask other resolvers from around the organization to come in and help me out. I need the network guy to actually come in and help me with a switch. Oh, this may be a DNS issue. There are different things, different components that are out there. I now start using corporate infrastructure to bring that team together so that we can meet virtually, whether that be over Microsoft Teams or in Slack. In the event of part of our systems go down and I can't use my internal communication tools, do I want to bring up an external conference bridge? How do I notify my customers? We're currently expecting a system slowdown. We're working the issue. So you post updates. Does legal need to approve that? Do they actually need to tell you that, hey, before you post notices to customers out on our website, we want to approve it? So being able to get them to respond quickly. And kind of the point here is I'm bringing all of this together as we're going through this system is part of that overall cyber threat environment. The human that works this as the lead for the response is now overwhelmed coordinating between systems. They need people to help them just to keep these updates and these things in place as we go through that environment. So how do we recognize if we're ready to kind of take that step? Are we ready to actually do a major cyber event? And one of the things that I've seen is that a lot of customers are very confident in their security tools. They're very confident in their network operations tools, and they say they are. And we'll get more into some of the industry standards around that. But what I typically find for most mid-sized small events, they have an initial response that might not be quite complete. And then I need that miracle worker engineer back on the keyboard inventing the rest of the fix. And how do we kind of tell if they're ready? Have we actually done that planning for a cyber breach? Do we know what to do? Our good security tool out there tells me they found, a specific hack that was coming in the system. It was a known threat. They've taken this to mitigate it. Did we actually lose some data? Do we need to tell the customer their data was compromised? Was it completely in-house? Did we create a ticket to go through it, make sure it doesn't happen again? As you see some of these other points, was the application actually designed to be secure and recover? Do I have a system recovery plan? That if I actually have that worst case ransomware attack that locks up my server, it's like, oh yes, George is going to go out and actually build us a new AWS system. They'll provision it. He'll take care of it. He's very good at it. Do you really have the time for him to be doing this with hands on keyboard? The actual capability is you can automate that whole process and go to a particular restore point, in your history and walk through all of that. What if your communication systems are down? That your network switches got hacked, that they're the ones offline. The servers are fine, they just can't talk to each other. And this idea, again, for anything that is a known threat, it takes a while, and over time you'll eventually build there, but you should have playbooks and responses so that as your monitoring tools find these defined and known threats, you should have a known recovery path for most of these. And that helps a lot with that automation in the system and knowing where to go because you thought about it early on. And we've kind of been talking strictly in the digital space, but to make this a bit more complex, what happens if there's a fire on your campus? You've got 3-4 buildings, server farm in one of them, but you've got another little small building that used to be the telephone shack that's now your circuit building. And that's where all your comm circuits come and go. And that's your hub for communications on campus. What if you have a fire in that building? How do you recover? If the fire actually gets big enough and takes the building out takes the equipment with it, what happens? How do you get replacement equipment? How long or how deep do you need to dig to grab those actual physical fiber cables, or hopefully not copper cables, and put them into new equipment and extend them so you get them back above ground because the fire took them out completely? And that idea of looking at, fire, the external things that go on to take your systems offline. Company out there, Delta Airlines, they have the mainframe environment, Deltamatic. And back in 2017, they had a fire underground in a conduit pipeline that actually ended up taking out some transformers at the end of the pipeline. So they lost both primary and backup power to their mainframe environments. So they no longer have a fallback. They're completely offline. And again, they thought they were good because they'd actually put a lot of money into their infrastructure. And kind of that real question is, what caused the fire? And in this case, I kind of followed that. I looked at some of the blog posts that were out there because I thought it was interesting at the time. And the best conjecture was down there in Georgia that you had some greedy mouse that was actually chewing on the pipeline cable and started the fire. And they had no way of putting it out. They didn't have a smoke detector in that underground tunnel to monitor it. So the fire was able to grow until it actually caused power to go offline. So that idea of, building a reliable system, planning for these threats to your systems. Cyber threats are not just cyber. They usually have somebody involved to go along with them. And one of the people that override all of this, insurance companies insure you against, loss of data, downtime. And one of the new breeds of engineers out there in the system is SRE, Systems Reliability Engineer. So their job is to help communication between all of these silos. And their focus is specifically on making sure the system is reliable, which includes designing from the beginning security, what if scenarios, making sure you know how to restore, making sure that a failover goes well. That if you have a fire just outside your server farm, a lot of places have the fire alarm system tied in directly to server management, and you're going to get an emergency halt operation on your servers to take them down and do the failover to the other location to protect them. What if we actually took 1.5 to 3 minutes to do that shutdown? We made it graceful. We sent out some notifications to customers we're moving to backup servers. You may experience some problems here over the next 30 minutes. While we do that, we'll keep you informed, and you gracefully take them down and transfer the data, as opposed to letting your fire alarm system just pull the power on your servers to protect them. Again, that role of that systems reliability engineer is to bring together all of these people. And that cyber threat containment, we've been hitting on this, requires planning. And why is that planning so important? We've got this great cyber tool. It's going to identify the threat. Oh, and I've already got, as we talked before, my response to that, SQL injection attack, hopefully those are gone these days. But it's like somebody wrote some new code, and when they checked in the code, it got scanned, identified the thing, and we fix it. But if it made it the whole way to production, How do we fix it? How do you get a developer to come in? Have you planned for that? And again, hopefully on that one it's resolved. But some of the stats about the industry and these attacks I find are kind of amazing. And they're, to me, honestly, downright scary. This idea that, oh, a hacker will come in via remote access, hack my switch, get to my server, plant something, and leave. In 2018, and it's gotten a lot worse since then, 30% of all cyber and data breaches were related because they had an internal human do something to enable that breach. And then we start looking at the actual data breach itself. They last on average 315 days. Takes 228 days to identify that a breach is occurring. So during all this time, hackers, Black World have been in your systems doing things, and your monitoring tools haven't picked up on it because they found a way to mask themselves as a known threat, and they're not there. And kind of that other point that the SolarWinds problem brought to life was that a lot of companies are still just beginning to think about it, but they're not doing it yet, which is designing in security from code check-in, from code writing to code design. That's why it's important to start from the beginning to make sure it's there and that only changes that are authorized are making it into your system. There are ways of doing that with two-person automated control to ensure that, two people verify this code, is good. Two people cooperating, to take your company down. Hopefully that's not the case. And you keep it easy so developers can move at speed. The automated tools are in place to start doing these things. But, kind of the question for you to sit back and think about is, with your monitoring tools, you're running your applications, you're making a good resilient server. Why does it take, on average, 7 months to detect the fact you've got a problem? They're something to think about. That's using the best of the best. This is the industry norm. Granted, there are companies that are better than that, but a lot of companies are out there trying. And the norm, the average, in 2020 was 7 months before you knew you were being attacked. And then comes the scary part. The industry average for cleaning up that attack is it's in my system for 80 days before I can get it out. So this cyber environment that we're in, it is not the time to be resting on our laurels that we have purchased some excellent monitoring tools and we've improved our processes. The stats say we still have a long way to go. And I am this proponent, and what we're after today is we need to give the team the ability to respond and automate, and more importantly, do the planning, the what if scenarios to find out how to do this. And kind of that key point that we can work on immediately at changing is this idea that the experts need to use their knowledge to respond rapidly. That I don't want them spending the majority of their time cutting and pasting the same data into different systems so that different groups can help. We should have each system, each group in their tool of choice, the tool that makes them most effective, and the automation and our capabilities, current technology should be sharing that data real time between systems so that we're marching toward the same solution through a known predefined thought process and plan. And if we kind of look at some of the stuff that's out there, using these type systems for automation, this idea of having that predefined workflow and having it something that it has a user interface that a non-high-tech engineer can help with starts to become important. And why is that non-high-tech engineer important? Let's think about the legal shop for a moment and some of the people that work with them. You're having a ransom attack. What does legal want you to do? Have you ever thought of how the insurance plays as you go through that? That if you start trying to fix it, the insurance company that has to back you up and help you recover your money that's lost, they may demand that you don't touch it and only their experts touch it. Is your IT team and dev team even aware that those type rules exist in a lot of insurance policies? It is predefined how to handle a ransomware attack. And if you deviate from that, you lose your insurance. The other side of the house is this moving quicker. I kind of talked about that a couple times here, but letting data move and be fetched based on known, thought out processes, workflows, that, oh, we know that SolarWinds, may detect that one of our switches gets overloaded, that it goes to 85% CPU for more than 10 minutes. We want to start doing something to shed some of that load before we overload it and cause an outage. Is that something that an engineer can get notified, push a button, and be done with the whole thing here in less than a minute or two? Or do they need to go between various systems and figure this out? Let them be supported by other folks that are out there. And kind of doing that, I want to take a look at this, on-call responder teams, the notifications that went through here before, that we want to transition from having a human in the center of this communication wheel to a human doing what they're good at, which is solving the problems, using their engineering expertise, and letting systems talk to each other, share data, and make sure that we're all seeing the complete picture. And some industry times out there for normal incidents, not a major cyber threat attack, but just responding to a known outage with an application. We've got a memory leak, we want to fix it. The application halted. We want to take care of that. We find somewhere around SLAs of 2 hours. Making sure that the customer agreement is that we're going to get you back online in 2 hours in the event of a problem. We find that the industry blows that. The typical response is about 2 hours and 45 minutes for someone to come in and actually do that they're typically not in a position to do that on average. We want to improve that by bringing automation into play and letting it go out when I get that signal that comes in on the system. I want to do something with it. I want to pull the rest of the data that human needs. And if I actually take that and put in place some artificial intelligence, because a lot of the detection and monitoring tools have some very powerful AI engines to take advantage of. We can start putting that together with pre-planned processes and automation and allowing my systems to integrate and share data. And I start bringing that response time down. And on this graph, what we're eliminating is not actual time solving the problem. This is the elimination of time that the resolver needs to go spend to research what's going on and make sure they come up and they're comfortable with the fix they have planned. So if we start looking at that into the system to see how modern AI might work as we go through all of this, systems could be out there, and instead of going after, my on-call resource and reaching out initially to my resolver that's going to kind of lead the incident, system sends out a notice. It goes to a common system that's going to go out now and actually, hey, am I receiving any other notices from other monitoring tools? Can I correlate them together? Am I getting a lot of the same one that's going in? A flood control, we want to monitor for that because that changes what I do. And I'm also going to see what has changed on the particular system or systems in question. Did we deploy new software? Do I have, known SEV2 problems against the software or the application that's very similar to what's going on? If so, I want to pull from that automated side initially here, all of this information together, pull as much background as I can to keep the human from having to do that. I'm going to take all that data along with that initial signal then and put it into the ITSM system. I'm going to create that ticket from which we're going to manage that overall repair effort, manage that incident as we go through the system, let it grow or shrink as appropriate. And then I start deciding, after I've looked at this, I've taken that analysis the system pulled together for me, I'm actually going to look and start calling in people, resolvers, that I need their expertise to help me do this. And I'll turn on and automatically create a Teams or a Slack channel just for this incident as we go through. If managers have a channel they monitor just for basic traffic, send them a notice that something's up. Use an internal conference bridge or optionally an external conference bridge in the case your phone lines are actually down, to bring everybody together, or maybe, even tell everybody to meet in a conference room if necessary. And the other part is we're working this and the information's flowing back and forth, and that resolver as well as the actual responder start working together to come up with an idea how to fix the system, call in the resources that are needed, we need to notify customers we're having a problem. We're going to be offline. Involve other folks in that notification as necessary. Go up our chain of command. Hey boss, we're having a problem. We're working it. Hey, Mr. Legal, and hey, Mr. Product Marketing VP, would you please actually approve this notification email we want to send out to customers, and we want to post this on our status page to customers. Is this okay? And get that approved, and do that all in an automated fashion. And use these resources between all of your systems and all of your monitoring tools to bring together that solution as fast as possible. Let automation work as well as it can work, and share data to make sure you have the complete picture. And when we finally resolve that, we want to make sure we do the follow-up work, that we've captured those tickets that went through. Oh, we did find, that Dynatrace identified that we actually had something. We kind of looked into it, talked to developers. We think it's an application defect. We want to make sure that code, we raise that ticket probably in Jira, because developers typically use a different system for tickets than the IT world. Bring together that after action report so our processes can be updated in the future. That continuous improvement, notifying customers, getting their feedback. How severe was this outage for you? Any ideas how we can help you in the future? Like if something like this happens again, to actually keep you online and working through all of this. And we're kind of doing this, in this broad overall sense. And what I'm really trying to get across here with this slide is, we may start with an incident from your security team going to on-call management to find out what's going on, actually doing some signals intelligence. What are our systems reporting? What's bringing together? But we want to make sure that we bring the right resources together to work this process. And the way we're going to do that is by pre-planning processes, workflows, how systems talks, and the steps we can take. For sure, we want to address known threats, and then we give you some generic principles that are out there, in terms of how to do basic stuff. One of the most common things you end up doing is restarting an application. That if you're offline, a simple restart, if it was automated, I get a signal in from Dynatrace or, again, another tool saying my application is hung. Actually working it, I just say, oh, restart it before I call the resolver. And then when I call them with their on-call person, I say, I've restarted it. The restart attempt failed. What do you want to do next? So that's all done. And we want all of this to go together so that you're in an environment where you can actually work, learn, and improve. And kind of looking at this, as we go through that, that automation concept of how we do things, so far we've been talking about that initial response reduction. I think that makes sense. These tools and these concept of processes can be applied to that actual, resolution phase, as well as to bringing the system back online after we know what we want to do. So these timelines can actually be improved even further as we go through the system. And at this point, I'm kind of sitting here and, we're talking about some of these things that are possible. And I'm wondering what it might actually look like as we're going through the system. What could something do for us as we go out there and do this? Come on, click. There we go. And so how does that type of tool, work? The idea that, maybe we find an event while we're out there that's going on in the system. And we want to see, what's happened, what's going through that whole world as we're working there. We've got these previous incidents you can be notified from, and with those you have built-in steps and resolutions that you can see. It's pulling the data together as you're walking through the system to make sure that things are ready to go and that you're sitting here in a really good shape. Sorry, here I wanted to show you one other thing, and as usual in a live demo, I clicked in the wrong place and killed my window. Sorry about that. So I will Here we go. Get it working again. So, this idea of being notified while you're out via text message, SMS message, with characters, email address, direct phone call, a phone response system. Here, I'm just using a app as we go through the system. It told me that it's like, hey, it's generating my alert that I want to actually demo to you. And then it's out here, and we're finding that, yeah, SolarWinds had a problem. That automation that we talked about, we took that information, we ran some known queries against it. We had planned about that in the past. So we went out and looked around in other systems. We found related to this problem that SolarWinds found, we actually had some code moved. In Bitbucket, we actually did some changes in that world. We see that the actual deployment that we did through Jenkins, it was completed, but it had warnings when it went through that system. So we know that the actual deployment that just went out was not completely stable. This idea that we've got other tickets in service now that go along with this, it's already pulled all this information together. So with my initial response, we slowed it down in reality, maybe, 5-7 seconds to pull this data together. And then from here, I can start taking actions. That is the expert, that on-call resolver. First thing I want to do is run automation. That I know that restarting the service, verifying that the code is in good shape as we actually go through that system is kind of what we're looking for, and how it comes together. And we want to, give it a chance to go back to the system there and restart. And what is doing that? In this particular case, this is our tool, low code drag and drop environment. Where did it scroll off to? And you bring in the different components that you've got. But here, what we're looking at is that initial piece where system's just being a bit laggy for me. Sorry about that. So that initial, signal that was inbound, we talked about it, went out and checked Bitbucket, see what was there, and you can see the different tools it walked through. And then finally, after it had collected all of this data, it grabbed it, actually put it into a notification that went over to the on-call list, figured out who was currently on call and on tip, called them and gave them notification how they requested to receive it, whether it be email, SMS message, or in the application. And then we go off and actually create an event to store this data and keep it moving in the system. And one of the things from there that kind of talked about drag and drop environment, that we don't need a full up integration coder, that you bring in components. And a lot of tools like us do this, that we actually want, fill in the information. It's already here. It's already scripted for me. It allows me to deploy near real time changes that walk through the system. I configure automation for how I'm going to do this, what information I'm going to actually send out the system, and this concept of flood control. If I'm getting a lot of these signals, what am I going to do? If I get the same error 4 times in 60 seconds, I go off and do flood control processing so that I don't overwhelm people with different components that are out there. And now you're seeing that, my Ansible restart has actually failed, so I need to take other action. So I can go in and actually look at my Ansible piece here, get a link back to that side. I'm aware of it. I was expecting it to fail because that's how I kind of coded it for the demo. And then that takes me back, so I continue working this at this point, that as a initial responder, that it's kind of over my head. And so from here, I'm going to go down and request either an incident, or I'm going to declare a major incident as we come out that other side. So I could push on one of those buttons and let that process come back and continue as I go through the system. So with that, that's kind of a lot of fast talking here, and I've tried to give you some ideas of things that to think about, which was kind of, from my perspective, the whole idea of the session. Do we have any questions out there?
So we do have one question, And so they ask, from a bird's eye view, what new learning should we be picking up from the Ukraine-Russia conflict? How to prepare for or pivot with a fast-moving cyber threat landscape?
Again,
So a little bit more timely.
Yes, and again, the basics are still there. That if you haven't planned for a worst case scenario or a modern scenario, that means you're going to be responding by trying to create a response. That if in this current situation, if you're in one of the countries that are being hacked, like you've got a server farm setting in Poland right now, I would probably be locking down, causing things to be a bit slower. In particular, a reverse DNS lookup authorization for every packet coming in. It slows the system down, but to make sure where it's coming from as we go through that system. But that's part of that planning process. What else could be done? The idea of, knowing we usually have a physical person involved in trying to take something offline, hey, do we have a backup data center that we can route our customers to, so that our customers sitting there in Poland, we can actually redirect through DNS to the backup site in France, and we consider that more secure or less likely, to be compromised. But that idea of definitely looking at that threat landscape, knowing that it's going to increase what's there, I kind of think is that key for planning. And if you're actually very concerned about being attacked, depending on how aggressive those things are getting, because I personally think there is a cyber wave of attacks coming here in the near future. We need to be monitoring for that and ready to take our services down, notify our customers. Thank you, Mr. Customers here in Poland. We're monitoring for unexpected cyber threats. If we start seeing them rise, we will take the service offline to protect your data and your service. And we will keep you informed in terms of when we think it's safe to bring it back online. Worst case scenario, but that's how you protect yourself. You turn off those switches, you turn off the router, you shut down the servers, and you sit there and wait them out until you feel safe, what was going on. Does that hit the point? My thoughts any good for you? Any more questions?
That's the only question I'm seeing so far, Tom.
Okay. So, kind of with that, I'll go back to summarize here. What we were trying to get across today, at least from my thought process, is if you're comfortable with your current monitoring and security tools, and you think you've got yourself protected, I hope I've got you to the point that you're going to go back and evaluate just how protected you are. What happens if that squirrel actually gets into the building? What happens if you have a person that's been paid as part of the cyber attack to actually plug in, a cell phone to one of your switches in the server room? How are you going to deal with that when that inside person purposely compromises your systems? Have you thought that far? And overall, I think the industry is in relative good shape because we have an actual lot of good people that are trying really hard to do things. That you just can't afford to become complacent. You've got to think about that worst case scenario and the ever changing landscape, and you've got to be ready to change and react quickly, and sometimes even extremely. That idea of shutting down a data center and taking your switches offline is an extreme step. But if you're not sure what you're facing and you are going to need days, if not weeks, to recover, it may be a good way to protect your resources. So with that, Cody, that kind of hits the high points there.
Well, excellent. I'm going to go ahead and give out some gift cards and just give our audience about another minute or two to send in any questions they might have. And I'd also like this time to remind our audience that today's session was recorded. So following this webinar, you'll receive an email with a link to access the on-demand recording. You can also find the recording living on the DevOps website. Just visit devops.com/webinars. So quickly, we do have 4 $25 Amazon gift cards to give away. Our first winner is Robert A. Our second winner is Amjad A. Our third winner is Trisha T. And our fourth and final winner is Kendra S. So congratulations. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. So Tom, I'm looking and I think we have concluded all of our questions for today. So I would really like to thank you for taking the time out of your busy schedule to be with us today, for putting together this demo, and hope that you have an excellent vacation coming up.
Thank you. Privileged talking with you. Thank you for the day.
Of course. I would like to extend our gratitude to Everbridge for sponsoring today's webinar. And my final thanks goes to you, our audience. We appreciate you being with us today for today's presentation. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future TechStrong Learning webinar. This is Cody J. Brown signing off. Have a great day, everyone.